So, as I told you in the last lecture, we started the solution of boundary value problems using finite Fourier sine or cosine transform. Just we started one example, but due to the shortage of time, we could not start it. So, let us see the problem now. Use the finite transform to solve del v del t equals k del 2 v del x square, where x lies between 0 to pi and t greater than 0. With del v del x equals 0 when x equals 0 and x equals pi, and t greater than 0, v equals f x when t equals 0 and x lies between 0 to pi. Here one thing is there, the function v is a function of two variables, if you see, that is x and t, where x lies between 0 to pi and your t is greater than 0. Since the t varies from 0 to infinity, therefore, I cannot use finite Fourier transform with respect to t, but x lies between 0 to pi. And if you see here, value of del v del x is given as, that is value of v x is 0 when x equals 0 and when x equals pi. If you remember, we told b f 0 t and v f l t, these two values should be known. And if it is known, then I can use the Fourier cosine transform. Therefore, from the given conditions and from the range of the parameters, we can decide that this particular problem can be solved using finite Fourier cosine transform with respect to the variable x. So, please note that it is with respect to the variable x, not with respect to t, since the value of x lies in a finite region 0 to pi, and also the first derivative with respect to v vanishes when at the initial and the final point, that is at x equals 0 and at x equals pi. So, let us see the solution of this particular problem. So, your problem is del v del t equals k into del 2 v del x square, and your x lies between 0 to pi, it has been told t greater than 0. So, as I told you earlier, apply finite Fourier cosine transform with respect to the variable x on the both side of the given equation. So, your left hand side will be 0 to L again, that is L is equals to pi over here. So, 0 to pi del v del t, I am using finite Fourier cosine transform. So, this will be equals to cos n x, because your formula was cos n pi x by L. This was, and L is equals to pi here, since x lies between 0 to pi. So, that this pi will be cancelled and this will become only cos n x dx. So, left hand side will be this, and on the right hand side you will have k into 0 to pi del 2 v del x square into cos of n x dx. Actually, whenever in the last lecture, when we started the finite Fourier cosine transform, then we evaluated the values of all these things. So, what is the left hand side? Again left hand side, like earlier example, since I am taking the finite Fourier cosine transform with respect to x. So, del del t can come outside, that is ddt form, and the integral will become 0 to pi v cos n x dx, and 0 to pi v cos n x dx is nothing but v bar c, that is finite Fourier cosine transform of v only. So, that this equals, you can write down d v bar c by dt. This is equals to k into this value I am directly writing, you will see it from there, minus n square into v bar c. You see the earlier lectures, directly you can get it, minus v x 0 t minus v x into pi t into cos of n pi. So, if I evaluate the value of this integral, in that case directly I will obtain this thing. Again, if you see from the given in the problem, it is given that value of this is equals to 0 and value of this V x pi t, this is also 0, because del v del x equals 0 at x equals 0 and x equals pi. So, that this term, second term entirely will vanish, and you can write down d v bar c dt, this is equals minus k n square into v bar c. So, by this way basically you are transforming your given equation PDE into one first order ODE only. The solution of this equation, will be equals to V bar c, this is equals A into e power minus k n square into t. So, that I can tell it that this is the equation 1. So, V bar c from the given ODE, the solution of the ODE will be equals to V bar c equals A e to the power minus k n square into t. So, I have to now find out the value of this one, V bar c, value of the constant A. Also, I know this thing, V equals some function of x whenever t equals 0. At t equals 0, your V x equals f x, it is known to us. So, therefore, I have to find out at t equals 0, V bar c is what? At t equals 0, V bar c from the definition, it is this one, V of x 0 basically at t equals 0 means V of x 0 into cos of say n y dy or anything you can use. So, I can write it V y 0 in terms of y if I write down. So, 0 to pi V y 0 comma cos of n y dy, where V y 0 is nothing but V is f x at t equals 0. So, that V y 0 I can write down, this is equals to 0 to pi f y into cos n y dy. And if you see at t equals 0, your V bar c is 1. From here at t equals 0, your V bar c, this is nothing but A, because this term will vanish. So, that you can write down A equals this thing, A equals 0 to pi this thing. So, 0 to pi f y into cos n pi d pi. Please note that your V bar c is this thing, that is V bar c is 0 to pi f y into cos n pi d pi. From here V bar c 0, this will be equals to simply f y c 0 means this term will, cos term will become 1 and this will be equals to dy. So, now V bar c, if I substitute the value here e power minus k n square t into 0 to pi e power minus k n square t will come outside. So, that it is f y into cos of n y dy. So, you obtain this thing V bar c equals, by substituting the value of this A e power minus k n square t 0 to pi f y into cos of n y dy, and also V bar c 0 equals 0 to pi f y dy. So, these two I am obtained. So, from here by taking the inverse finite Fourier cosine transform, from the definition I can write down your V x t, this is nothing but 1 by pi into V bar c 0 plus 2 by pi into summation n equals 1 to infinity V bar c into cos of n x, since L your L is equals to pi. So, please note that the inverse finite Fourier sine transform and the cosine transform, the values are different, not same. So, I had the V bar c, from there I am writing V x t, this is equals to 1 by pi V bar c 0 plus 2 by pi summation n equals 1 to infinity v bar c into cos n x. So, depending upon the length L or the range of x, only this formula, some places in cos and 2 by L will come, nothing will change. So, v bar c 0 already we evaluated from the earlier slide. So, 1 by pi this is equals to 0 to pi f y dy plus 2 by pi summation n equals 1 to infinity. V bar c value now you have to put, that is e power minus k n square t into cos n x. This is coming, then the integral will come 0 to pi f y into cos of n y dy. So, we have to stop here because I do not know the value of f x. In one of the condition it was told that v is equals to f x. Since I do not know the value of f x, so I cannot evaluate the integral in both cases, but if I know f x, I can evaluate the integral and I can tell the solution is v x t in this form for the given partial differential equation. So, like this way I can find out the solution. Let us just see this one. This was the original problem for you, and you are taking the finite Fourier cosine transform with respect to x. Again I am repeating, in the earlier example also I explained why I have to take finite Fourier sine transform. In this case also, if you see your x lies between 0 to pi, t is greater than 0. So, t cannot be considered, and the initial condition is given as at x equals 0 and at x equals pi, the first derivative of v, that is del v del x, equals to 0. Since this is given and I know to evaluate, I need the value of del v del x at x equals 0 and at x equals L, that is pi here. So, I will use the finite cosine Fourier transform with respect to x to solve this PDE. Please note this one. So, whenever problems will be given to us, in that case I have to decide whether I should use finite Fourier cosine transform or finite Fourier sine transform, depending upon the range of the variable as well as the conditions provided to me. So, by applying the finite Fourier cosine transform, I am getting this 0 to pi del v del t cos n x dx equals k into 0 to pi del to v del x square into cos n x dx. So, left hand side will be again as usual d v bar c equals d v bar c v c bar, where v c bar is nothing but the Fourier cosine transform, finite Fourier cosine transform of v, and the right hand side we have done earlier already. I am directly putting the value k into minus n square v c bar minus within bracket v x 0 t minus v x pi t into cos n pi. If you recall the from the given conditions, v x 0 t, value of v x 0 t is 0, value of v x pi t is equals to 0. So, that the entire second term will vanish and only the first term on the right hand side will be there. So, that your given PDE is converted into an ODE of the form d v c bar dt equals minus k n square v c bar, and the solution of this ODE is v c bar equals a e to the power minus k n square t, where a is a constant. To find the value of this at t equals 0, your v c bar equals 0 to pi u x 0, u x 0 has been given as, if you see, v equals f x at t equals 0. So, therefore, for this case it will be at t equals 0, v c bar equals 0 to pi v x 0. In place of v x 0, we are substituting f y into cos n y dy. So, I will obtain a equals 0 to pi f y cos n y dy. So, that v c bar will be equals to, by substituting the value of a as e power minus k n square t into 0 to pi f y cos n y dy. And once I am getting the value of this b c bar, that is the finite Fourier cosine transform of b, then using the inverse finite Fourier cosine transform, I can write down Vxt equals 1 by pi Vc bar 0 plus 2 by pi Vc bar n pi n into cos nx, and I am putting the value of Vc bar 0 and Vc bar n, and I am getting this equation, and this is the solution of the given or PDE, which is in the form of Vxt. Please note that the condition was given that B equals fx at t equals 0. Since fx is not available to us, therefore, we cannot evaluate the integral, we have to leave it in this particular form only. Let us take one more example, so that it becomes very clear to you for how to find out the boundary value problems using the finite Fourier sine or cosine transform. Given problem is, I have to use, I am telling finite Fourier sine transform. To solve the problem, del 2 u del x square equals del u del t, where x lies between 0 to L and t greater than 0. It is given that u 0 t equals 0, u L t equals 0 and u x 0 equals twice u 0 into x by L, whenever x lies between 0 to L by 2, and twice u 0 into 1 minus x by L, whenever x lies between L by L to L by 2 to L. So, if you see here, t is given as greater than 0, time can take any value from 0 to infinity, although x has a finite range, that is from 0 to L, and also the value of the function u at x equals 0 is 0, value of the function at x equals L is also 0. So, from the definition of finite Fourier transform, we know it that if I have to find out, if I have to use the finite Fourier sine transform, then value of u 0 t and u L t must be known, and this is known in this case. Therefore, to solve this particular problem, we will use the finite Fourier sine transform. Let us see, let me just first write down the equation del 2 u del x square equals del u del t. X lies between 0 to L, t is greater than 0. Of course, u 0 t is given, u L t is given, sorry, yes, and this is equals also 0, u x 0 is also provided. So, you apply finite Fourier sine transform with respect to x on the both side of the given partial differential equation. So, you will obtain as 0 to L, your this one will be, I am just writing del u del t at this side into sine. Here the range of x is from 0 to L, so that it will be sine n pi by L into x into dx. This is equals 0 to L del 2 u del x square into sine of n pi by L, sorry, this is n pi by L into x, this side will be x. Similarly, here also it will be sine n pi by L x into dx. Now, left hand side, again since you are taking finite Fourier sine transform with respect to x, so del t can come out as an dt, and this integral will become 0 to L u sine n pi by L into x dx, which is nothing but finite Fourier sine transform of u. So, that you can write down d u bar is dt left hand side, whereas in the right hand side, just for this case I am breaking it. Let us just check what happens if I directly evaluate instead of putting the value del u del x into sine n pi by L into x. Your x will vary from 0 to L minus n pi by L. I am using integration by parts only, 0 to L del u del x into cos of n pi by L into x into dx. So that this equals, you will obtain at 0, it will be vanishing. So, you will obtain del u del x into sin of n pi x by L minus, from here you will obtain n pi by L into u will come, del u del x was there, into cos of n pi x by L x equals 0 to L. I will put the limit together. This I did not evaluate at the beginning. So, I am just putting this minus n square pi square by L square 0 to L u x t into sin of n pi x by L into dx. So, first I am making integration by parts, and then again I am making integration by parts on the second integral also, and this becomes 0 to L u x t minus sin n pi x by L dx. This integral, if you see, this is nothing but the Fourier, finite Fourier sine transform of your function u x t, that is u bar s. Now, if I substitute the limits on this, what I will obtain, that is, I am writing here. So, you will obtain d u bar s dt. Second term I am writing first, minus n square pi square by L square into the given integral, as I told, it is nothing but u bar s, which is a function of x, plus if I put the limits on the first term, you will obtain n pi by L into u 0 t minus u L t into, sorry, this will be cos n pi. Now, u 0 t and u L t, this function, this value are given as 0. u L t is also given as 0 from the physical conditions. So, that basically this second term vanishes and your equation, given equation becomes d u bar, sorry, not d square, d u bar s dt plus n square pi square by L square into u bar s, this is equals to 0. So, your given PDE is converted into an ODE in this particular format. General solution of this one is u bar, which you can write down u bar s, this is u bar s, which is a function of x t c e to the power minus n square pi square by L, n square pi square by L square is there into t. So, I have to find out the value of this thing now. You know it that 0 to L u x 0, sorry. So, u bar x t is equals to c e power minus n square pi square by L square into t, and the value of this constant I have to find out. Now, what is your u bar s x 0? That is, at t equals 0, what is the value of this? At t equals 0, it is nothing but 0 to L u x 0 into sin n pi x by L into dx. From the definition, I can write down this u bar s x 0 equals 0 to L u x 0 into sin n pi x by L dx. Now, if you remember, u x 0 has been given as two functions, one between 0 to x lies between 0 to L by 2, another one for L by 2 to L. Two different functions are provided over here. First one I think is 2 u 0 into x by L, second one is 2 u 0 into 1 minus x by L. So, that This integration now I can break it into two parts, 0 to L by 2 plus L by 2 to L, and where value of x 0 will be changing to u 2 naught into x by L and 2 u naught into 1 minus x by L. So, if I substitute it, I will obtain u bar is x 0. This is equals to 0 to L by 2 twice u 0 into x by L into sin n pi x by L dx plus L by 2 to L twice u 0 into 1 minus x by L into sin of n pi x by L dx. If I evaluate this limit, you will obtain, I am just not evaluating this because you can evaluate of its own, you should check it of your own. You will obtain 4 u 0 L by n square pi square into sin n pi by 2, this you will obtain. And also your u bar s equals c at t equals to 0. So, from these two I can tell that c is nothing but this quantity, and this I can write down from here, c equals, it is 0 if n is even, otherwise I can write it as 4 u 0 L 2 m plus 1 whole square into pi square into sin of 2 m plus 1 into pi by 2 whenever n is odd. Or this directly I can write it, c equals in one terms minus 1 to the power m 4 u 0 into L into, by substituting this value, 2 m plus 1 whole square into pi square. So, once I am obtaining this value of c, therefore, by substituting this value of c into u bar s t, you can write down u bar is x t. This is equals minus 1 to the power m 4 u 0 into L divided by twice m plus 1 whole square into pi square into e power minus n square pi square L divided by t square. So, if I now take inverse finite Fourier cosine transform, then u x t will be equals to, sorry, finite Fourier sine transform, because we have taken the finite sine transform here, u x t will be 2 by L summation n equals 1 to infinity u bar s x t into sine of n pi x by L. Now, if you substitute the value of this u bar, this thing you will obtain 4 is there. So, 8 u 0 by pi square, I am bringing it outside, summation over m equals 0 to infinity, I can make it minus 1 whole to the power m 2 m plus 1 whole square e power minus n will be 2 m plus 1 whole square. So, minus 2 m plus 1 whole square into pi square into t by L square. This I have written wrongly, actually this will be L square and this t will come here. So, please note that this term is minus n square pi square t by L. This term is this one, please note this. So, it will be minus twice m plus 1 whole square into pi square into t divided by L square into this sine term will come, that is sine of twice m plus 1 by L into n, I am replacing this into the pi x. So, this is the solution of u x t. So, let us see quickly. This was your original problem, and the original problem, from the definition, from the given conditions, I have to apply Fourier sine transform with respect to x. So, applying finite Fourier sine transform with respect to x on the given side, on the both side of the given equation, I will obtain this. So, left hand side will be du bar s dt. This I am explaining how I am breaking it earlier, although I have shown it earlier, but for this problem I have shown again using integration by parts twice. I will obtain this, and once I am putting the value of my this thing, I will ultimately obtain du bar s dt equals in u 0 t minus u l t into cos n pi, but u 0 t and u l t, these values are given as 0. So, therefore, your first term will vanish. Oh, there is a mistake. In the given ODE, du bar s dt plus n square pi square by L square into this will be u bar s, not u, equals 0, because you are getting the ODE in terms of u bar s. The solution of this is c e to the power minus n square pi square L square by t. Now, u bar x 0 I can write down from the given definition as I have shown you earlier, 0 to L, which I have broken into two parts, because value of u bar x 0 u x is in 0 to L by 2 one function and L by 2 to L another function. So, I am breaking this thing, and if I evaluate these two integrals, I will obtain the value of u bar s x 0 as 4 u 0 L by n square pi square into sin n pi x by 2. And also at t equals 0, u bar s is c. So, that your c will be basically this last quantity. So, c I can write down 0 if n is even and if n is odd, this particular expression. And in one way I can write down in terms of m and 2m plus 1, I can write it like this value of c. So, that u bar s t I am writing this and using inverse Fourier sine transform from the definition 2 by L n equals 1 to infinity u bar x t into sin n pi x by L. Substituting the value of u bar x t, I can obtain this particular value. So, like this way I am getting the solution. So, I hope it is clear to you now that whenever I have to solve a boundary value problem, and in the boundary value problem for a particular variable we have a finite range, that is 0 to L, how using either Fourier cosine or finite Fourier cosine or finite Fourier sine transform, how to solve the boundary value problem by using the finite Fourier sine or cosine transform, convert the PDE into a first order ODE, find the solution of the first order ODE, find the value of the constant using the given conditions, and once you know the u bar s or u bar c, that is Fourier cosine, finite Fourier cosine or sine transform of the function, using inversion formula always you can find out u x t using this particular form. So, by this way I can use the finite Fourier sine or cosine transform for solving the boundary value problems where the variables are provided in a finite range.